All right, so let's bring up our final finalist for the 2016 Discovery Education 3M Young Scientist Challenge. Our final finalist is Rohit Mital from Rochester Hills, Michigan. Let's give him a warm welcome. All right, my friend, you're up. Good luck.
All right, thank you. Good morning, everyone. My name is Rohit Mital, and I will be presenting my mat innovation that is used for mounting ceramic substrates in emission control devices, such as catalytic converters and particulate filters. On the left is a converter schematic showing the substrate, the mat, and the metal shell housing. Using the force balancing equation, we can see that the mat has to provide enough compressive force to counter the back pressure from the exhaust and the acceleration forces that the substrate will experience. Yet it has to do so while not exceeding the isostatic strength of the substrate as it's being compressed to achieve that holding force. So you may be thinking, 3M already has a vast portfolio of mats, so why do I need to invent a new one? In a previous project, which I submitted for the Young Scientist Challenge in my video, I had designed a triangular cell filter which had much higher surface area and lower back pressure than the corresponding square cell filter, which is actually in production today. So my prototype was built here, and testing confirmed my analysis results that use of this filter could save the US millions of gallons of fuel a year. So why isn't this filter already in production, you ask? Well, in the past, extrusion, the removal of these triangular shapes of these cells and wash coating them with the catalyst has been difficult because the wash coat would plug the channels of and the corners of the channels, and that would reduce surface area. These issues are all resolved now, but what remains is the strength of this substrate. It has stress points at the corners, and so it has significantly lower isostatic strength than the other filters, and it cannot withstand the canning process. And hence, there is a need for an innovative support mat. I hypothesized that my new design would fix all of these shortcomings and significantly reduce the pressure that is put on the substrate. So, to solve my problem, I first did a case study to evaluate the performance of currently available mats from 3M and other suppliers. Using the force balance equation, I calculated the minimum mat pressure that would be required, and I calculated the peak pressure that the substrate would experience using these peak pressure curves. Out of the 15 or so mats that I investigated, only 5 passed my hypothetical case study, which was already less severe than the actual requirements because otherwise no existing mat would have passed. The mats that failed either did so due to high peak pressure or low holding force. Now, with these down-selected mats, I tried to identify all the common features that make them so good. It was obvious that non-intumescent mats or hybrid mats with low binder content were desirable. It was also obvious that for the hybrid mats, the vermiculite content should be low, and the fiber type was always best as polycrystalline. As is obvious from the force balance equation, a higher coefficient of friction is desirable. By varying the coefficient of friction, I could see how the minimum holding force varied, and a lower holding force requirement means that a substrate can be canned at a lower peak pressure, and that means that it's going to avoid all possibility of substrate damage. I came up with 2 ideas to increase the coefficient of friction. The first was to introduce micro-sized silica particles during manufacturing, and the second was to add a texture to the surface of the mat. Finally, a prototype was created using my required characteristics. There's a shell side and a ceramic side. I decided to keep the 3M vermiculite on the ceramic side based on heat transfer, so it heats up faster and can expand faster. I used polycrystalline fibers from 3M to make this sample, and I also fixed these silica particles on the surface of my mat using 3M Super 77 adhesive. And finally, it was time for the defining moment. It was time to see if my new mat, designated SPR 142 by 3M, could pass the new tests. The peak pressure data, as shown there, was just marginally better than currently available mats. However, the coefficient of friction showed significant improvement. It's almost double what you'd see in currently available mats. So using this new data, I recalculated the safety factor and the holding force and the peak pressure. And as you can see, with a constant safety factor, about 1.12, similar to the first mat, 1.15, the peak pressure reduced significantly. That's okay.
Thanks, Rohit. It sounds like you've made some nice advances in this area. I do have a question for you. Maybe you can explain to us what is a binder, and maybe you can give us a couple of examples of representative binders.
Sure. The binder is basically a glue that holds all the tiny, tiny fibers together in a mat. So here I have two other mats that are from a different supplier. This one, as you can see, is more rigid, and that's because it has binder in it. This one, however, is a lot more flexible because it has no binder and the fibers aren't being held together by a type of glue. So that's basically what the binder is.
With the growing use of electric cars, how could you adapt your innovation to meet those challenges?
Well, obviously, in an electric car, there's not exactly an exhaust system. So there wouldn't be filters, and there wouldn't be a need for a mat. But I suppose I could always try and look at the systems that are in electric cars and figure out a way to better support some maybe other fragile components of the engine or systems that go in, which is basically what I did here.
Thank you, Rohit. Excellent research. Certainly, the processes that you've been through has generated some questions. What next for moving forward?
Well, I feel like there's a lot of ways I could improve this sample mat. I might look at better fastening techniques for the silica sand because currently the 3M Super 77 would off-gas completely, and so this would be compressed in between this substrate and the mat, but there could be some better fastening techniques. Also, I could look at some more options for whether is hybrid actually the best, using both expansive material and non-expansive material. There's a lot of different facets that I could improve in the substrate.
Thanks. Do you have a slide on the references and research that you did?
I do not, but I can tell you some of my sources. Dieselnet.com was where I found a lot of my information. I also worked with a couple of suppliers, one for the substrates, the actual, which is NGK, and I worked with Tenneco for the actual mat data, and 3M's automotive division helped me create this
One other
sample.
quick question. What's the chemistry of these fibers that you're trying to have the binder stick to?
So what actually happens when manufacturing a mat is basically there's lots of fibers which are put into some water and binder, and it's basically a solution which they blend up and then form into these, I like to call them cakes. And so as it dries, it slowly expands, lets the air in, and that's basically how they're formed.
Great job. Are these replaceable items that'll go in the car? And if so, is there a comparison between your model versus currently available models?
These aren't exactly replaceable materials because they're welded into the shell. So I suppose, I don't know exactly how they do it, but when they were testing my prototype, they did have to rip out the substrate because it was uncoated with the wash coat, and then it was coated again and put back in. So I suppose you could rip out the substrate and replace the mat. It would be difficult though, but I do not have any actual data with the same car, same situation, my mat versus others.
Great job. How did you decide on this project?
So a couple of years ago, I visited India, and it's particularly difficult to breathe there because of all the cars that pass through, and there's obviously automotive pollution everywhere. And so then when I came back, I did go to the Detroit Auto Show, and there I saw my first engine mock-up, which I could mildly understand. And I was interested in the lump that came at the end of the exhaust system. And that's how I kind of started researching that, and I ended up with this.
So obviously the Detroit auto manufacturers are fairly well established in working with stuff like this. So how is it that you entered into something that was already so established and found your niche?
Well, when I started researching, I was able to find that for these substrates, nobody actually looked at using triangles because there was research done and they found that it did perform well, better than a square, but again, it was weak, like I said. And so that's when I found that maybe I could use these high-performing substrates if I created a mat that could support them.
Awesome presentation.
Thank you.
Ooh, I liked it a lot. I wanted to know, when you're testing your mats, do you put them on the back of exhaust pipes? How does it work?
3M's automotive division tested these for me, but at least for my sample, since it was just an 8 by 8, I think, they weren't exactly able to keep it with an actual filter and put it in a car situation. So they probably just used frictional instruments to test how the friction would work and stuff like that.
You did great. That was awesome. I'm going to have you stay out here for a second. All right. Real quick, can I have the other 9 finalists? Can you come down here? Join me? Nice job, by the way.
Thank you very much.
All right. Just kind of huddle in here. Nice job. All right. You guys feeling good? All right. Couple on the side over here. All right. Good, good. All right, so for everybody that's watching, everybody here, another round of applause for our 10 Young Scientist finalists. All right, so for those of you that are watching, thank you so much for joining the webcast. Make sure you follow the hashtag Young Scientist tomorrow on the website and on social media. We will announce the top Young Scientists for 2016. So thank you so much for joining us. Congratulations to all of you. Thank you to the mentors and parents. So on behalf of Discovery Education and 3M, thanks for joining us, and we'll see you soon. Bye.